Okay, we are back and we're going to get a little bit deeper into emulation and we are going to perform a dry run on our program. Now, when we first test this program, it is ideal if we can actually test it on a PLC, which is not connected to any inputs or any outputs. Possibly it's connected to a test stand which has switches to simulate digital inputs. It has resistors or potentiometers set up to simulate analog inputs, but it's not always possible. Sometimes as soon as that PLC comes in, it's hooked directly into the machine, or sometimes we're programming from the other side of the world and we never even see the PLC. So in that case, you can go ahead and do a dry run on an emulator. But if possible, and you can get access to the PLC without it being connected, it's always best to dry run with the actual PLC. In our case, we're going to be dry running on the emulator. So we've got our PLC program in RSLogix 500. It's already connected and online with the emulator, which is running the program. And now I'm going to go ahead and bring up the HMI, which was developed in FactoryTalk View Studio SE, which is Site Edition. That creates HMI programs that run on a computer rather than on a dedicated HMI screen. So once this loads, we'll be able to see the process graphics of this system, and we're going to be able to start simulating machine functionality live right now, just as it would be working if it was connected to a live system. Okay, almost started up. And there's our graphic. You see it looks a little strange because it's still establishing communications. Once it gets communications, then everything knows what color to be and what numbers to fill in, and then we have a viable process graphic. So let me walk you through this mess of an HMI that I've developed for this course. In the top left of our window, we have two push buttons, System On and System Off. And below System Off, we have a status indicator which is telling us what mode our system's in. Below that, we have blower control, the top being an indicator that says the blower's either running or not running. Then we have our three buttons, blower in hand, off, or auto. That's our HOA control. And then below that, we have an indicator telling us which mode our blower is actually in. On our top right, we have a tank alarm indicator which is going to turn either green or red depending on whether we have alarms or not. The tank alarms consist of a high level and a low level. We have temp alarms which consist of a high temp or a low temp. And we have pump alarms which consist of a low flow condition or a high pressure condition. Below that, we have our familiar alarm reset and alarm silence buttons. And then if you see these two blue squares down towards the bottom on the left and right, to the left we have some set points for temperature, a high set point, an operating set point, and a low set point, the high and low being alarm conditions, the set point being the value that we're sending to our PID control and asking it to sustain. And in the blue box on the right, we have our four basic analog limits. We have low, high, and high. There is an analog sensor detecting level in this tank, but we also have a high, a high, a low, and a low switch. Now in a normal tank, you're not going to have that much redundant controls, although you might have one high switch or a high and a low switch. It's very doubtful you're going to have a high and a low. But in this case we do, and that's strictly for demo purposes. We have here a discharge valve, which is where the water is leaving the tank, and that valve is going to open or close and change colors, so is the pipe, determining whether or not there's flow through that line. We have a level indication in the bottom of the tank, which is giving a scaled representation from 0 to 100% of our level. On our heater, we have the actual temperature that we're reading below, 104 degrees Fahrenheit, and above that we have a heater output percentage on a scale of 0 to 100. Then we have our pump and our blower, which all turn red or green depending on whether they're energized or de-energized. So right now our system's down. Let's go ahead and click System On. And now we see our blower comes on, and the blower and its pipe turn green, and so do this pipe to the right going up, because that's where the blower's venting out from. Our pump is off at the moment, and if we look at our discharge valve, that all turned green, so we know that's energized. So if we look in our PLC program right now, let's go ahead and click into Digital Outputs, and here we can see exactly what our PLC program is doing. If a bit is energized, you see how it's highlighted green along the rung, and if a bit's de-energized, you see that it's not highlighted green. And likewise, on the right for our actual outputs, we can see them either highlighted green or not highlighted green depending. So our blower is highlighted green here, and when we come to our HMI program, since we have an animation for color programmed onto that blower, it's turning green because right now that bit that it's looking at is energized. So let's test our blower HOA. If we click off, our blower turns off. If we click auto, then our blower comes on because we're running. But if we turn our system off, then the blower shuts off. If we put our blower in hand, our blower runs even though our system's off, and we can turn our system on and off, and because our blower is in hand, it'll stay running. So it looks like our HOA controls are working exactly as desired. So now let's turn our system back on and finish this dry run up. The next thing we want to look at is our pump, and we say we want to check and see if our pump comes on when it's supposed to and goes off when it's supposed to. Well, the way this pump is programmed, it's going to energize when the level in the tank gets down to the low level, and it's going to de-energize when the tank level reaches the high set point. So to test this, let's go ahead and change our low level to something higher than the water level in the tank, and after a brief delay, our pump should energize if everything's working correctly. So I'll go ahead and set that to 67, and after 5 seconds, our pump turns green, and what happens next? All of a sudden, our pump turned red again, and we see that we have a pump alarm. So let's go into the program and see why we have that pump alarm. So we'll click into our alarms ladder, and we'll scroll down to the bottom where we have our categorical alarms, and here we have our pump categorical alarm, and we see that's been triggered because of a low flow alarm. So when we scroll back up to see our low flow alarm, we see right here that this is where the alarm occurred, and this is the condition that triggered it. Our fill pump was energized, but our flow switch never closed, which means our pump was turned on and energized and running, but it didn't create flow for 5 seconds. So the program shut off our pump to protect it from cavitation. So that's how we can see that that alarm is working. Now when we go back to our HMI program, we can click our alarm silence button, and that's going to terminate the notification of the alarms. You see everything turned green again up here. But when we go back to our program, we see that even though our notification is now de-energized, the alarm condition is still present, so our alarm silence is working as desired. Now we can click our alarm reset and make sure that it went ahead and, sure enough, disabled that alarm. But that alarm's going to come back in 5 seconds once our pump tries to run again, and sure enough, that works exactly as we designed. So that's how we do a dry run on a system. We need to go through our program and test every single function, every single alarm, every single device, every HOA control. We need to test every set point, every button, every display on our HMI. And testing everything on a full-size program is a pretty time-consuming process, but it's 100% necessary part of this process. In the next section, we're going to look at forcing I/O, toggling bits, and how to make the PLC think something is actually happening in the real world that isn't. And that's going to be the second half of conducting a dry run. So stick around and we'll get into that functionality next time.